Hi and welcome back. So in the past video, in the past few videos we started talking about the S block. In the last video we were talking about the P block, and I said in the last video we were going to start talking about the D block. I actually want to do just maybe a couple more examples of P block elements, so we can get maybe a little bit more experience, doing P block electron configurations before we jump into the D block. So let's just for I'll actually maybe I'll actually you know what, here I'll scroll up a little bit so we've got a bit more space. So just for some practice, let's maybe do the electron configuration for oxygen. Oxygen is right there on the periodic table. It's a P block element, so that means that the last entry in our electron configuration, and we can tell that our last entry. Actually, this is maybe a good way to talk about it. We know that it's in the P block. Oxygen is in the P block, and it's also in period 2. So we know that our last entry, if we're going to write the electron configuration for oxygen, we know that our last entry is going to be 2p something, okay? And to start off, we can actually say that we know that that beryllium had completely filled up. Anyway, I'm getting a little ahead of myself. Maybe I'll talk about that in a sec. But so anyway, we know that our last entry is going to be 2p something. So let's first start filling up from the bottom. So we start out with our 1s orbital, and we have got that completely full, so it's got 2 electrons. So then we move to our 2s orbital, and we start out with an electron configuration of something like lithium. That would be 2s1. But we know that our 2s orbital is going to be completely full, so we're going to have 2s2. And so now we're going to, and maybe, I'll erase that and move it a little bit closer. There we go. And so now we're going to start filling our 2p orbital, and we know that this is going to be our last entry for our configuration of oxygen. And how many electrons do we have to fill up? We know that oxygen has got 8 electrons because oxygen's atomic number is 8. And we know that we already have 4 electrons in our configuration, so we know that we are going to have 4 electrons in this p orbital, and that'll give us 8 electrons overall. Another way that we could kind of have figured that out is by counting across the p block. We could say that all of the elements in this row, and I'll scroll up a little bit so you can see that, their last entry is going to be some number. Let me start erasing a little bit so I can maybe do this a bit more cleanly. There we go. Okay, sorry about that. So anyway, if we were going to look at this column, we could say that all of the elements in this column, their last entry for their electron configuration was going to be whatever period they were in. So if we were looking at gallium down here, the period would be 4. If we were looking at indium, In down here, the period would be 5. And I don't know. I guess I didn't. Oh, it's already underlined. But if we were looking at indium, the period would be 5. If we were looking at aluminum, the period would be 3. So anyway, it's going to be whatever period we're in, then it's going to be the p orbital because we're in the p block, and then all of these, how many electrons are they going to have in their last p orbital? All of them are going to have 1 electron, right? Because we've completely filled up our whatever period we're in s orbitals, and we're also going to see we'll have filled up our d orbitals as well for these other elements, and we'll only need 1 electron to go into our p orbitals. How about this column right here? This column right next to it. Well, you can see that, each of these elements, they're only going to have one more electron than the element directly to their left, right? So we could say that all of these elements, their last entry is going to be whatever period they're in, then P2, right? And then you can imagine that to the right of them in this row right here, they're going to be whatever period, P3. In the row starting with oxygen, we're going to have whatever period, P4, then P5, and then finally our noble gases, the very last column on the right, is going to have whatever period we're in, P6. So with that, let's actually do another orbital configuration. Actually, I'm going to clear off my writing, except I'm going to just remember that this is the D block that we're looking at. Let's do the let's do the electron configuration for chlorine. So we know that this is in the column that we said that our last entry is going to be, move that over, is going to be whatever period we're in, P5, right? And let's count down the periods again. So we've got 1, 2, 3, 4, 5, 6, 7. We can see that chlorine is going to be in our third period, right? So if we were going to write out chlorine, so let's do Cl, we're going to write out chlorine's electron configuration. And we're looking at the neutral atom, so we need 17 electrons. So we start out with our 1s orbital, 1s, and it's going to be completely full, so that's going to have two electrons in it. Move to the 2s orbital. So 2s, again, it's going to be completely full, so we have 2 electrons. Then we move all the way across to our p orbitals, so 2p, and the p orbitals are also going to be completely full. So we're going to have 2p6. And so how many electrons do we have right now? We've got 10, right? So we need to keep going up to 17. So now we're going to add on our 3s orbitals, and we're going to have those completely full. So we're going to have 3s2. And now we're at the point where we're in our last entry. So we're going to take our period that we're in. Our period is 3. So 3. And then we know that it's in the p block, so we're going to have p orbitals. And we're in this column where we know that our last entry is going to be whatever period P5. So we're going to say that this is 3p5. So how many electrons do we have? We've got 2 and 2 plus 6. That would be 10, 12, 17. So this would be the electron configuration for chlorine. So anyway, hopefully that gives you a little bit of maybe a good bit of practice. Maybe I think I do this in a future video, maybe one of the electron configuration example videos. If you want to try doing it yourself, maybe try doing the electron configuration for phosphorus on your own. So anyway, I'm actually going to end the video right now, and in the next video we're going to start talking about this block, which is the D block. So anyway, thanks so much for watching, and I'll see you in a future video.